When analyzing malware, one of the first things you might want to look at is strings. Now you might wonder what is strings. If you don't come from a programming background, you might have not heard about strings before. So strings are pieces of text. It usually is written between two quotes like this. It can also be single quote, can be one character or multiple characters. For example, if I open the console here on JavaScript and I clear all this stuff, you'll see this is a string, but this is also a string, or this could be a string. So it doesn't matter single quote or how many words or how many letters, all of those would be considered strings. Now, if you have any application, any malware, doesn't matter if it's for Android or for Windows, you can get those strings out of the application. Any readable text, you can extract it from the application. So they give some explanation in this TryHackMe room. So from the programming perspective, the strings is data handled by the application, and they are pieces of data with information, and 99% of the time is just text. They can put numerical values in there, but it makes more sense to do that as text. So they give some more details about that. So strings are very important in programs. And developers, programmers, they often don't care too much about security, so they will leave credentials in applications like an Android app or other apps where you can simply get the username and password from. A lot of developers really don't care. They have 9 to 5 and they want to get home. So you can get all kind of information by analyzing the binaries, by analyzing the malware or the application. You can read out all kinds of text information. So there is some example here that they store sensitive information inside their applications. So if you can extract those strings, those text values, you can then extract sensitive values. So they give an example of Italian. They work on satellite communication, so it's not like the standard database company or read, write, update, delete data from a database app, some simple web app, but they're doing something more sophisticated with satellites. And what they did, you see here is that company, is that showing some information, general company information. So this company, they disclosed some information and they had a default passcode of 1, 2, 3, 4, 5, 6, 7, 8 stored in their application, right? Not the most secure idea. So they give an example here of an Android application that has string data inside, has readable text with sensitive information. So here you see a username, a password, and another password. Now they say, what is the name of the account here that has the passcode 1, 2, 3, 4, 5, 6, 7, 8 in the example discussed above. So it could be that it is Italian, or it could be something else. You could try probably something else. No, there we go. So then they ask, what is the CVE? CVE is the vulnerability disclosed by the company Teradata in their viewpoint application. Okay, I have to read that again. What is the CVE entry disclosed by the company Teradata in their viewpoint application that has a password within a string? So we would have to find that information, Teradata, and look for that. Some quick search, and we find that this Teradata company hard-coded the passwords. So that happened in 2019. You see CVE 2019 and that number. And here is the password. So they ask, what is the CVE entry? So that's this CVE entry. This is the code of the vulnerability, the number or identifier. Then they say, according to the OWASP list of top 10 IoT vulnerabilities, name the ranking this vulnerability would fall in. Now, this can depend on the year. Let's see if they have some hint about this. So they say for 2018, which is a while ago. Let's see, check that out. So, see if we can get some more. You can open this one. 2018. So in there, there's hard-coded password is number 1. So number one vulnerability, they simply store the passwords and other sensitive information right in the applications that you can easily read those. So name the ranking this vulnerability would fall in. Okay, I guess that was 1. There we go, 1 spelled as an English 1. So to read data from applications, from binaries, from malware or whatever app you have, you can use a tool called strings. It's a command line program. So you'll see it works like this: strings followed by the name of the program. And if you want, you can save the data. Otherwise, it's going to print out all the data on the terminal. So inside this example, inside task 2, what they're doing is simply a very long way to explain this strings program. Now I can show you a simple real-life example, which will save you a lot of time instead of reading all this text. So we can download the task files. You'll see we have an executable. Then I open a terminal. Then I go to the downloads folder, so cd downloads, and you'll notice I download a program called login form. So to investigate this program, to get all the strings out, we simply type strings followed by the name of the program. Notice that the strings program must be installed. If you're on a Mac, you can install it with a tool called brew, B-R-E-W. On Linux, this should be installed by default. It is also in the attack box on TryHackMe. So make sure to add the extension. In this case, it's a Windows program, a .exe. And if I press enter, what it's going to do is output all of the text data that it can find inside. So you see there's lots of text data here. You see they're doing something with privileges. And if we scroll up, we see some kind of functions here for the computer system. And if we scroll up, maybe we find other things. So there's something like input your password. And here we see a flag as well. So all we did was the strings command followed by the name of the application. So that's gonna extract any kind of string in an application. It doesn't matter if it's a Windows application, a Linux application, an Android application, or whatever application. It simply will extract all the text data. Now let's see these questions. So they ask about the flag. We saw that already. So we can actually filter this. We can do grep and then search for the flag, which usually starts with these curly brackets. So it simply filters the output. If you add this pipe and grep, you can search for any words and it will filter it, so we don't have to scroll so much. So let's copy the flag and then move this guy. Then they say what is the required password to authenticate with and the username. So let's see if we output the data again. You can actually do it page by page if we add this less. So you see first is a bunch of bogus data and says it cannot run in DOS, the old Microsoft system. So if we scroll down, we see here a short name. This could be a username, but it does seem to be kind of the same length. So let's try to copy this. And for simplicity, let's move this thing to the side of the screen. So let's check. There we go. And let's move this thing to the other side. Okay, then let's continue. We go back to 2. And they ask us what is the password to authenticate with. So might be that this is the password, seems to be about the same length. Let's try and copy and paste it. And there we go. So we got all of this sensitive information out using the strings program. Now I press Q to quit, get out of the screen. So with the strings command followed by any application, it simply is going to read out all the information it can find. And sometimes an application can have sensitive information. Okay, on to section 3. We'll do strings in the context of malware. So in this case, they say that developers can be lazy, which is a bit of an understatement. They leave passwords in applications as previously discussed. And how does this relate to a malware analyst? So professional developers can slip up, as they say, or they might simply be tired and want to go home. So malware developers know different. So malware, many different types of malware, just like there's many types of programs. There can be information stored in it, like where does it connect to, what's IP address, where they're going to call home, is there a command and control server, maybe passwords, and so on. So they have an example, WannaCry malware. It's been a while ago, but it was very widely spread around the world. And they had a kill switch domain by accident. It was simply a string value, and I believe they killed the domain in which the malware no longer worked. So they say here, what is the key term to describe a server that botnets receive instructions from? So a botnet is simply a computer that's impacted. There can be hundreds of thousands of them, and a single computer can send commands that those bots, those computers, will then execute. And they do that, they have a very fancy name, command and control, or CNC. So let's paste that in. And then they say, name the discussed example malware that uses strings to store one Bitcoin address for payments. So where they actually say pay this to this Bitcoin address, this Bitcoin wallet. This is a Bitcoin wallet address where people were forced to send Bitcoins in order to unlock their files. So they say name the discussed example malware that uses this crust and so on. So that is the WannaCry ransomware. Then here we can type the address, which is this address. So we can simply copy it. And click yes, then administrator and the password. And we also need to add some domain. Okay, let's do that. So let's copy this password and this string. And then we could save the password, why not, and click OK. So it's going to connect to the remote desktop if the information is correct. As it is, we'll see it's starting this Windows computer. So on this Windows computer, there is the command line tool strings that is provided by sysinternals. This is like a software you can download on Windows. And then you have the strings command line tool. So they want us to open the command line. Let's make this thing a bit bigger. So this is the Windows computer. Then we enter the folder sysinternals in desktop. There's a cd desktop, cd sysinternals. Yeah, cd, whatever it's called, systop. And then there is strings.exe. And you'll see that starts string.exe. But as input, of course, we need to give it some program name. In this case, we need to accept the license first, okay? And you'll see it just outputs some general information, the help of the program, how to use it. So what we need to do is start strings.exe with some program name. In this case, this complex calculator version 2.hex, which I don't know where it's stored. Let's take a look. Might be simply in this folder. Yeah, there it is, complex calculator version 2. So what we can do is do strings.exe, complex calculator, and then you see this greater than that saves the output into the file name you type after it. So in this case, do strings.txt. If you don't do that, it simply outputs it to the screen. If you add this, it's gonna save the command line output to the text file strings.txt. So I'm gonna press enter. And now we can open that file in Notepad. So we can say Notepad strings.exe or txt. And that's gonna show all the data that instead of in the command line is now in the text editor. So they have some question. What is the Bitcoin address stored in complex calculator? So we're looking for a number or a string that is quite long. Bitcoin addresses are typically quite long. They are this length. So let's see if we can find one in this simply by scrolling down. You see there's quite a lot of junk data in this calculator. Okay, so after searching for a while, we find this Bitcoin address inside this notepad, which means that this Bitcoin address is stored in the application. We can copy this, hopefully, and then we can paste it in as the address, the Bitcoin address stored inside that Windows program. They also say about a transaction here. So this has nothing to do with the strings thing, but there's a transaction in the Bitcoin wallet. They have a link here of the WannaCry and what was the first date. So we can simply open this with the blockchain explorer and you'll see different dates. Now 2024 is not the first date, so we can go all the way to the end here. So the first one is in 5/12/2017 here at the end of the line. So that is, well, let's double check again. It was 12/5. They have this American format, 12/5/2017. Okay, that was wrong. 12/5/2017. It does seem to be the first one. Let's see. We have the month here, the day. Now it could be it's in reverse, that we got it wrong. Let's try this. There we go. And sometimes that happens with these different formats around the world. So that's it for this room. No, they have some more questions. So they say, what is the name of the toolset provided by Microsoft that allows you to extract the strings of an application? So we use the strings application. It's not installed by default. You need to install that sysinternals. You see, we installed that in somewhere in this course. So that's sysinternals suite or sysinternals. Then they say, what operator would you use to pipe or store the output of the strings command? So how do you save the output? Normally, if you run the strings command, it's gonna simply write to the folder. So let's say, to give you an example, if you just run strings.x with any application, like that complex calculator, it's outputting everything to the command line, right? It's not usable unless there's very few. So you can use the operator greater than to store it into a text file. So let's say greater than strings.txt, and then inside strings, sorry, not strings.x, but strings.txt is then all the strings. So it's the greater than operator. And they say, what is the name of the currency that the ransomware often uses for payments? So that used to be Bitcoin. And there we go. We completed this room.